Hello everybody and welcome to Chopstick Maths. Today let us learn what are complex numbers. Square root of 25 is plus 5 or minus 5. On squaring 5 we get 25 and on squaring minus 5 we also get 25. So this confirms that 5 and minus 5 is the square root of 25. However, square root of negative 25 is neither 5 nor minus 5 because on squaring plus 5 or minus 5 we do not get minus 25. Rather we get 25. So if plus 5 or minus 5 is not the square root of negative 25, then what is the square root of negative 25? Let's find out. Consider this property of surds. Root of AB is equal to root A into root B. Now we can write square root of minus 25 as square root of 25 into minus 1. And now with the help of this property we can write square root of minus 25 is square root of 25 into square root of minus 1. Let us define a number iota which is equal to minus 1. On squaring both sides, iota square is equal to square root of minus 1 the whole square. So iota square is equal to minus 1. So iota is square root of minus 1 and iota square is equal to minus 1. We have these two results which we'll be using. So let us substitute, instead of this root minus 1, let us substitute I. So square root of minus 25 is equal to phi I. So let us check if phi I is the square root of minus 25. So on squaring phi I, we get 25 into I square, which is 25 and I square is minus 1. So phi I square is equal to minus 25. So this confirms that square root of minus 25 is equal to phi I. Now based on this, let's see some few more examples. Square root of minus 36 is square root of 36 into minus 1, which we can write it as square root of 36 into square root of minus 1. So square root of minus 36 is equal to 6i. Square root of minus 5, we can write this as square root of 5 into minus 1, which we can further write this as square root of 5 into square root of minus 1. Replacing minus 1 again by iota, we get square root of minus 5 is equal to square root of phi I. Now the next example, square root of minus 16 over 25. We can write this as square root of 16 over 25 into minus 1, which is equal to square root of 16 over 25 into square root of minus 1. Again replacing square root of minus 1 with iota, we get square root of minus 16 over 25 is equal to 4 upon 5i. So square root of minus 25 is phi I, square root of minus 36 is 6i, square root of minus 5 is root phi I, and square root of minus 16 by 25 is 4 by 5i. So let us define a number ki, where k belongs to real numbers and I is equal to root of minus 1. Such a number ki, we call it an imaginary number. And here are a few examples of the imaginary number where we have worked out. Phi I, 6i, root of phi I and 4 by 5i. Now, a number of the type z is equal to x plus iy, where x belongs to real numbers and y belongs to real numbers, and I is equal to root of minus 1. Now, such a number you can call it as a complex number, where x is called as the real part and y is called as the imaginary part. And here are a few examples. 3 plus phi I, minus 2 plus 3i, minus 4 minus 3i, and 1 minus I. These are all complex numbers of the type z is equal to x plus iy. Now when the complex number z is equal to x plus iy, when x takes the value of 0, because x and y both are real numbers and 0 is a real number. So if x takes the value of 0, then the number z becomes a purely imaginary number. And here are the examples. Z is equal to 0 plus 3i, that is z is 3i, and z is equal to 0 minus 2i, that is z is equal to minus 2i. Such a number is purely an imaginary number. Now, when y takes the value of 0, then the number z is purely a real number. And the examples are z is equal to 3 plus 0i, which can be also written as z is equal to 3. And another example, z is equal to minus 5 plus 0i, which can be written as z is equal to minus 5. In this case, the imaginary part y has taken the value 0. Now, when x and y both take the value of 0, then the number is z is equal to 0, which can also be written as z is equal to 0 plus 0i. This is again a pure real number. So when x and y both take the value of 0, the number is z is equal to 0, which is purely a real number. So now we can say that every real number is a complex number, but a complex number is not a real number, because a real number can be expressed as a complex number, but a complex number is not a real number. Also note that for any complex number z is equal to x plus iy, x is called as the real part, which is denoted by re into bracket z, that is the abbreviation, and y is called as the imaginary part, denoted by im bracket z, that is the imaginary part of the complex number. So z is equal to rez plus imzi. That is, the real part is the x and the imaginary part is y. Right? So today we have learnt what is a complex number. Thanks for listening.